Welcome back. I think it's been very long time, almost 3 months. We have left our discussion. Okay, let's continue it. Today we are going to discuss about significant figures. So, what do we mean by significant figures? First of all, we should know. So, what happens? Generally, we report any value. For example, we have doing some experiments and we are recording some values there. So, we report the value up to one uncertainty. Some digits are certain, which are reliable, and along with those reliable digits there is one uncertain digit, and combining all these things we call significant figures. For example, I am taking an example here, then it will be more obvious to you. So let's say you are reporting length of a line segment. So let's say you are saying it is 4.2 centimeters, and you are using a scale of 0.1 centimeter. So what is happening here? This is certain digit for here, and this 2 is uncertain. So combining these two things, we say 4.2 centimeter is significant figure for this measurement. Now, if we are taking another example, let's say you are measuring time period and you have reported the value time period of a simple pendulum, let's say, and you have reported the value as 2.52 second. So the instrument or the stopwatch you are using here, let's say it has least count of 0.01 second. It can measure this much value, the smallest value, with certainty. So what is happening? This one is certain figure here. This one is also certain figure. We can say figure or digit. So these two are certain digits, and this one is one uncertain digit. So combining all these things, we say that these are significant figures. So here we can say there are three significant figures in this measurement, three significant figures. And here in this measurement, we have two significant figures only. So in this way, we report any value and we report with significant figures. Now, why I'm saying that this digit is here uncertain? So there is reason behind it. If we are using scale of 0.1 centimeter, let's say this is, so let's say you are using a ruler, and here you have 4 centimeter, and then 4.1, 4.2, 4.3, and 4.4, 4.5 here, and then you have further, let's say 5 centimeter marked here. So if the line comes, the end point of the line segment comes exactly with this mark, then we can say okay, this is 4.1 centimeter. If this line segment comes up to here exactly, we can say the length of this line segment. We have here the things, but let's say this end. Here the one side should be coinciding with 0. So we can say this is 4.2 centimeter. But there is a catch here. If we are taking a line segment and that line segment falls just just ahead of this 4.2 mark here, but not close to this 4.3. Still, we are going to report this thing, this length to be 4.2 centimeter. So, and in other case, if this line segment falls just behind of this 4.2 mark, here 4.2 mark is there. So if the line segment falls just behind this, again we are going to report the value 4.2 centimeter. That's why this last digit, this one, is uncertain actually. If it is exactly falling up to this 4.2 centimeter, then good. But if it is somewhere near, not very close to the other points, but close to this 4.2 mark, and then Again, we are going to report this thing as 4.2 centimeter, although it is not exactly coinciding with that mark. That's why we are saying that this last digit is uncertain. Okay, so I hope you got a clear picture about saying this to be uncertain digit. So let's move ahead. This way, if we are going to report with reliable digits along with one uncertain digit, so this reported figure is called significant figure. Now, there is one thing, and it is also important. A choice of change of different units does not change the number of significant figures or digits in a measurement. This should be very clear. For example, let's say if you are taking a measured value and you have reported it to be 2.308 centimeters, let's say, and then you have converted this value into, let's say, in millimeter. So you are going to write it 23.08 millimeter. So no matter you are taking it into centimeter or in millimeter, you have always four significant figures. As this reported value has four significant figures, this one, this one, this one, this one. Here there are also four significant figures. And remember, this last digit is uncertain. So in this way, if you are changing in another unit, let's say if you are changing the same thing into some micrometer, let's say, so there will be 2308 and then 10. Okay, so this is in micrometer. Again, we have four significant figures. Now, how to decide how many figures we are going to consider, or how to decide the number of significant figures? There are some rules we have to follow actually. So those things we are going to discuss just now. Before our further discussion, let's make a point here. Why I am saying that even if we are changing the units in which the values are reported, the number of significant figures should not change. So the reason behind this is we are using some instruments, or maybe let's say if we are using a scale to a ruler to measure the length of this line segment. So once we have measured this line segment, the length of this line segment, and we have reported the value, let's say 4.2 centimeters. Now, if you are changing the unit, let's say 42 millimeters, we have not changed the actual instrument which we have used here to measure the length of this line segment. So if we are not changing the instrument while changing its reported value in different units, it means we have the same precision no matter in which unit we have represented this value. So if we are not changing the instrument, we are not changing the precision of our measurement, and then we should have the same significant figures. So that's why I'm saying that merely changing the units are not going to affect the number of significant figures. Okay, let's continue to discuss some rules. How should we determine, how we determine the number of significant figures? The first thing, rules to determine the significant figures. The first thing is all non-zero digits are significant. All non-zero digits are significant, no matter where they are in the reported value, but they are significant. So let's take an example, then it will be more clear. Let's say in our previous yes, something 2.308 centimeter, let's say. So here 238. These three digits are significant, and of course there is second rule also here, because we have four significant figures here. So what happens actually, if there is a zero between two non-zero digits here, this zero is between 3 and 8, and these two are non-zero digits, so this is also significant. In that way we can write here, so 0 sandwiched between two non-zero digits is significant figure. Okay, so in that way, here we have four significant figures. Moving to next rule, and that is if we have reported a value in such a way, let's say 0.002. This is a reported value. Let's say. So what is happening here? Here, all zeros. Look, we have reported a value with decimal, and all zeros before any non-zero digit here are non-significant, or you can say insignificant figures. So this is a case where zeros are insignificant figures. But what happens if uh, we write here 4? Then these zeros are also significant figures because they are in between two non-zero digits. But let's continue our present discussion where there is a decimal, and in this value there is one non-zero value here, and before this non-zero value all digits are 0. So these all digits are non-significant. So this is one case. So we can write it as third rule. How can we write? All zeros before a non-zero number are insignificant figures. Okay. Now there is another case. Let's say we have reported a value as 2.0 centimeters. Now, what should I say this about this zero? Is this significant or not? So this zero is significant figure actually. Now there is nothing to be confused about this thing. Here is also decimal, but this decimal point has a non-zero value here, and before that non-zero value, before this 2, all digits are zeros. There is no any other non-zero digit here. So these are insignificant. But here what is happening? We have reported the value 2.0 centimeter. Here this 0 is significant figure. Why I am saying this? Because this 0 is actually indicating the precision of the instrument. That is, we can say the scale we have used is of 0.1 centimeter list count. That's why we have marked here 0. That is, up to this we can measure this length with the taken instrument. So this is significant figure actually. If we are writing, let's say another example, 42.280, let's say meters. So this is also significant. After decimal, if we have zeros, those all zeros are significant figures actually. But look here, what is happening? There is no any non-zero figure here or before. If let's say if there is another example, let's say let's move to another slide. Let's say 0.0102 centimeter, let's say. So this is significant figure, this is significant figure, and this 0 is coming between two non-zero digits. So this is also significant figures. So there are three significant figures here. But what about this 0? This is non-significant figure here. This is also non-significant figure. So in this way, we are going to say that this reported value has three significant figures. So I hope up to here you got a clear picture about these zeros, how we say that these are significant figures, these are not significant figures. Okay, let's move to the next one. Just a minute. Let's take one more example. Let's say we have written here 200 millimeter. So generally what happens? all trailing zeros are insignificant. That is, if we have to say that how many significant figures are here, so we will say only one significant figure here. These trailing zeros are non-significant generally. But what happens if we are measuring with an instrument which has least count of 1 millimeter? Then we can measure up to here. Then we can measure 201 millimeter also. So in that case, this zero will be significant figure. So this is a little bit confusing, but you should not be confused. Which one is this? I think fifth number. So all trailing zeros are non-significant figures. But there should not be confusion about this. If we say that yes, we have an instrument, we have used that instrument which can measure to 1 millimeter, then this zero is also significant figure. Then there will be three significant figures here. So this may be a confusing thing, but you should be very careful about this. So to avoid this confusion, we can report these values in scientific form. So let me discuss it once again. Then that trailing zeros are insignificant figures. So if there is something written 1000, okay, 1000 meters, let's say. So these three zeros are insignificant. But what will happen if we have measured this 1000 with the help of a scale of least count 1 meter? Then we have capability to measure up to here. And in that case, we have four significant figures here. But this 1000 meters, if we have uh, measured something 1 kilometer, let's say, and then we have reported the value in other terms, in other unit, 1000 meter. So we have taken the scale which can measure 1 kilometer precisely. So we have measured this 1 kilometer distance, but we have reported this 1 kilometer in meter only. And then we have 1000 meter. Then these three zeros are non-significant here. The only significant figure is 1. So it depends how many significant figures are there. It depends on the resolution or the list count of the instrument we have used. So to avoid this confusion, what we actually do, we represent these reported values in terms of scientific form. So how can we do that? Let's take the same examples. Let's say we have measured 1000 meters with a scale of 1 meter, and then we have to represent this. So we can write this thing as 1.00 and 0 into 10 to the power 3 meter. This is 1000 meter. But what happens here? After decimal, we have three zeros here, and as we have discussed here, let's say in this example, this zero is significant because this is reflecting the resolution of our scale. So with the same argument, we can say these three digits are also significant figures. So by representing this way, we have content that we have four significant figures here. Okay, now moving to another one. We have reported a value of 1 kilometer and we have used a scale of resolution 1 kilometer. And then we have reported this thing into 1000 meters. So here we can write simply in this way, but yeah, we can write it in this way. It is also reflecting that there is only one significant figure, as we generally take that only the non-zero digit is significant and all trailing zeros, if there is no decimal point anywhere, all trailing zeros are insignificant. So how can we write this thing? We can write this thing in scientific form like this: 1 into 10 to the power 3 meter. So uh, we have just converted this kilometer into meter, keeping the number of significant figures unaltered. So here we have one significant figure, here also one significant figure, but there may be confusion that we don't know about the resolution of the instrument, then we can't say that it is only one significant figure or here we have four significant figures. So to avoid that confusion, we can write these things in scientific form. Here you can see easily that is one is only significant figure. And here you can see there are four significant figures. So in this way we can write. Let's discuss more about the scientific notation. Okay, just a moment. Scientific notation. How can we represent a number? Just we have represented here. So we are going to generalize this concept. Let's say a into 10 raised to the power b. This is a form of scientific notation where this is, we can say, order, and this is your value here. So you can say this a should be less than 10 and it should be, generally it is greater than 1 we used to write, because if we have write 1000 meter, we can write it 10 to the power 3 meter also. So and no matter if we are writing 1 into 10 to the power 3 meter, this is also good. So but generally we used to avoid this thing 1 into something, we used to write only the order here. Now so a should be greater than 1 and less than 10, because if it comes to 10 then we can rise power by 1 here, and then b should be any integer. B belongs to integer. Now if we are going to write the order, let's say only order. What do we mean by order? Let's say we have 10 to the power 2, we can say the order of this value is 2. Or we have, let's say, 1000, then we can say this is 10 to the power 3 and the order is 3. Okay, in general, if we have something, let's say 800, we can write it 8 into 10 to the power 2. So here we should be careful about saying what is the order of this value. So here we can see that is okay, there is 10 to the power 2, and then we can say the order is 2, but it is not exactly what we should do. We can do one thing here. We have to take care this value also while reporting order only. Okay, so why should we take care? Because let's say there is one value 200 also, and there is another value 900 also. This you can write 2 into 10 to the power 2, and this you can write 9 into 10 to the power 2. So we have general convention here that if this value is greater than or equal to 5, let's say, then what we do to just estimate the orders, we represent this a one order higher, and if it is less than 5, we estimate this value to be unit order. So with this argument, we can say this is of order 2, because we can write this thing 10 to the power 2, and this we can estimate to be 10 to the power 3. So order of this value is, this is a kind of crude representation of order. So okay, now we are going to end our discussion here with the last statement that the multiplying or dividing factor, which are neither rounded nor numbers obtained from any measurement, have infinite number of significant figures. So what does it mean? That if we have, let's say, we can take an example and then we can discuss what is this. Let me write this statement for you first, and then we can discuss it. Here I have written the statement for you, and let's take an example, then this statement will be more obvious. So let's say you are calculating radius of a circle, but you have measured its diameter only. So if you have measured its diameter, you have to divide it by 2. This is dividing factor here too. And now this factor is not rounded off. This is only dividing factor, and this factor 2 is not obtained from any measurement. So how many significant figures we can consider here by just observation, you can say there is one significant figure. Okay, this is good. If you have measured the diameter to be 2 centimeters, or let's say 2 centimeter, okay, then radius will be 2 by 2, that is 1 centimeter. But if you have measured this value to be 20 millimeter, okay, or you can say 2.0 centimeters, then there are two significant figures here. And if you are dividing this value by 2, which has only one significant figure you have considered earlier, then at the end, we are going to discuss about those things after arithmetic operation, how many significant figures we have to retain and what are the rules for retaining the number of significant figures. So you will see that here we have two significant figures in the measurement, and after dividing this value by 2, we should have a result which has two significant figures. But that will be happening only when we will consider that this value has two significant figures, this 2 has. So in this way, if there are 10 significant figures in this diameter, then you have to consider, no need to write 20 here actually, then you have to consider that this value 2, this dividing factor 2, has 10 significant figures in order to retain the number of significant figures in the result. So this is a very important statement we have to keep in mind. So up to here uh, for today, and in the next class we are going to discuss rules for arithmetic operations with significant figures. Because when we are going to add or divide or multiply with different numbers of significant figures, we have to retain the number of significant figures in such a way that our results should be unaffected. At least it should have minimum effect result. So for those arithmetic operations with significant figures, we are going to discuss in next topic, next class, of course. And then we will discuss about rounding off or estimation of uncertain digits. So these two things we are going to discuss next. So that's all for today.